you, everyone. Last session of the day.
Oh, yes.
Woo, you guys made it. All right, so I am pleased to introduce our next speaker, Indrasis Mondal from Hulu. Indy currently is Director of Data at Hulu for Big Data Engineering and Data Products. Before Hulu, Indy worked at Getty Images, the world's largest talk media company, as the Director of Data and Analytics Product Management, primarily focusing on developing strategy and capabilities to enable data democratization and data products. Indy has more than 15 years of strategy, product, algorithm, and technology development experience in the area of big data, analytics, data science, IoT, AI, and location services. He will be presenting a talk titled Enabling Real-Time Exploration and Analytics at Scale to Drive Operational Intelligence at Hulu. Please join me in welcoming Indrasis.
Thank you. There's two things that stood out in that introduction. One, there were a lot of clap because I'm the last man standing between you and drink. So I'll try to remember that. And the second is the title was really large. So I actually cut it much, much shorter. So I think that title was really, really long. Again, my name is Indrasis. To make everyone's life simple, I go by Indy. That generally works much better. I work for Hulu as the speaker just announced, and I'm looking into data engineering and data products for Hulu. And today I'm going to talk about real-time operational intelligence in Hulu, and especially how we're enabling real-time decision-making within the tool that we've built within Hulu. This is sort of a very high-level agenda of my talk. I'm going to introduce operational intelligence, what it is. And I mean, I think a lot of people in this room might be a very new concept for people. We'll introduce the capability at Hulu. We want to talk a little bit about buy versus build, a question that often comes up. We'll introduce a high-level architecture and especially dive deeper into a couple of components that we've built. I'll try to defy Murphy's Law and try to do a demo. So I'll keeping my finger crossed. We'll see how that works. And then we'll have a few use cases on about operational intelligence. I'll bring some challenges and lessons we've learned, and hopefully we'll have time for questions. One other thing, I realize I don't have a clicker, so I have to sort of stand here and do this. So what exactly is operational intelligence? It is a kind of analytics capability that allows you to get a pulse, a real-time pulse of your business operations. In contrary, a business intelligence, mostly it's an analytics capability that allow you to sort of understand and improve your business over time. And the way I generally think about it, it's actually this picture right here. It's like driving. You know, the windshield of your car is your operational intelligence. You're driving, you're constantly looking at what's coming to you, and you're making choices as you drive. And if you're not careful, you know what it just hit you. On the contrary, BI is like your rear view mirror. It's like you have already driven away wherever you want to go, and looking back and see, okay, how have I done, how I'm going to improve. Again, this is not a concept that from me, so there are some references. If you get the slides, you should be able to dig more deeper into it. The operational intelligence at Hulu, the tool itself is known as Glyph. It's an internal product, it's an internal name, and it empowers Hulu to easily draw insights into our real-time data, and mostly event-driven data. So some of the capabilities we have within the tool itself is obviously you can explore real-time data at a very, very large scales, and I'll talk about the scale in a bit. It allows you to do interactive query in the real-time data. You can create dashboards. You can create real-time dynamic funnel to understand the conversion of it. And then we also have API services that connect to different component, different technologies within Hulu. We can provide the real-time services. Primary usage is obviously getting operational intelligence and reporting around, especially around this kind of data: user interaction, product usage, video quality, and app and device performance. Part of this talk, I'll also try to walk you through the journey we had about designing this, developing this tool. It started a few years ago where there was not really a very useful tool to do real-time analytics at this scale. So when we started this, there were some guiding principles we wanted to do. Mostly, we want to have a tool that can answer or help answer event-driven data, mostly understanding user interaction, app health, and the quality of service. And we also should be able to do the visualization and exploration within that tool. We also had some assumption and requirement, if you will. The main stakeholder of this tool were mostly product manager, technology, engineering operations, and an analyst. We wanted to make sure that all the ad hoc queries are time-bound, so which means you're doing aggregations around time, and the data is available real time. The data is aggregated, not sampled. I think that was a key fundamental requirement we have because the data quality is extremely important for us and the accuracy of the data. And you can't really have accurate data if you are sampling the data. We also want it to be extremely fast. That's why the delay in actually getting the query is not necessarily a query delay. So we wanted to make sure the query delay is negligible. If there is a delay, maybe it's a data availability question, not a query performance questions. And if you guys know about CAF theorem, so obviously we wanted to focus on the availability and the partition tolerance, and we wanted to make sure we had a batch layer that can provide eventual consistency. So why build? And again, this is a question often comes. This is a question my manager often asks me. This is a question I've been asked multiple times. So one of the reasons we built this system, when we built it, there was no product or vendor out there who could do this at scale. So the scale and performance was key. The other thing really important for us is the consistency of data. I mean, if you used Hulu app, we have so many different platforms. We have product sort of applications for. We have web, we have mobile, we have living room, we have Roku. So how can you ensure that you have consistency of all this data, and those data are not like saying different things. We talked about accuracy and quality a little bit. The coverage is, again, an important thing to make sure that we can cover the entire depth and the breadth. So depth in terms of our entire user base and the breadth in terms of our entire technology stack and the platform we operate on. And then integrations. How can you have a product that integrates across the entire Hulu technology stack? So when we started building this product, obviously we ask ourselves these questions, and there's nothing that could do that. We still ask ourselves this question. We haven't found a single solution that can do that. So we continue to build. Here's some big picture numbers of our scale. So we generally, as a Hulu, we develop or generate around 8 terabytes of data, app data each day. We process around 150,000 event data, which is roughly 10 million per minute in our real-time stream. We have 1.5 terabyte Druid ingestion per day. Druid is one of our core data store for real-time, and I'll speak about that in a bit. The data delay from the moment app generates the data and we can make it queryable is only 5 seconds, so which is not the query time. It's just the time it takes from all the way from the generation to actually making it available. Our average response time from query is only 250 milliseconds. So you can see how fast the system is. Our P95, which is 95 probability, is only 1.1 seconds. So again, it's extremely fast. And it's also one of the most used and adopted tool within Hulu. 50% of Hulu employees use this tool. And then the last, we'll talk about a little bit about data, how we source and store data within Druid, but one of our largest data sources is 0.5 terabyte. That doesn't speak much, but that's just one store. We have multiple different stores within Druid. This is a very high-level architecture. Just a little bit talking about, you'll see a lot of relevance with some of the other sort of topic we covered today in different conference rooms. All the way from the left is our client team submitting data. We have a real-time endpoints which is collecting the data, and then we're splitting it up in both in the speed layer and as well as our batch layer. In the speed layer, obviously we're adding a little bit more intelligence as we go along the way. We're filtering the data, we're sessionizing, we're aggregating, and then finally that data lands in our Druid, which is our main store for this operational system. And then on the batch layer, we're making sure we can correct any sort of data gap, any consistency, and storing that data back in Druid. And then, Druid is our key sort of data store for Glyph, but to make Druid usable for us, we have to build a lot of key component and capability within our system. So we had to build an API that can hide complexity within the Druid. We had to build a CAS, and obviously we had to build a UI system so that people can actually use this data. And those are the 3 areas I'll focus a little bit in the future. If you have any question on this slide, hit me in during the QA and we can talk more about it. So how many of you actually know what Druid is? Let's have a show of hand. Very few. So Druid is extremely fast, again, sub-second latency, highly scalable columnar data source. It supports streaming data, so you can actually ingest data in real time, and which becomes immediately queryable. It's built for Lambda architecture. Druid supports both a real-time node and a historical node, so you can make some data available in real time, some data in a historical query. It's highly distributed, and obviously that means it's highly scalable and available. We talk about sub-second response time, and it also allows automatic data summarization. So as you ingest the data, it can sort of summarize the data in your time scales. And that's, we talk about that's one of our key sort of selection criteria when you end. But one of the fundamental problem with Druid, and if some of you were used to it, it's extremely complex to use. Druid is complex in terms of actually so making sure we can do from an engineering management point of view, but it's also complex for user to actually interact with it. So there's some of the things that we learned along the way was like the configuring Druid as the data ingestion happens to Druid is not the most straightforward thing. So to do that, we had to come up with a few strategies. And one of the strategies we came up with, we wanted to make sure that all the high volume and the high complex data has its own storage. So they map to their own dedicated data source. What that means is now you can individually sort of control the retention and scale up that. So maybe some of the high volume data you don't need for more than 15 days. So you can actually control that. So you don't explode your storage. It comes with a little bit of higher indexing cost. If some of you have used Druid, don't probably know what that is. But that's a trade-off we were willing to make. At the same time, we also make sure all the low volume data can merge into a common data source. That way we can reduce the indexing cost, but with a little bit of cost of storage. But since they're not high volume, we can take that trade-off. We also wanted to simplify our ingestion type. So instead of do it as a columnar storage, so you can actually categorize all the different columns. And we came up with a very, very simple column strategy. We only categorize the column into 3 things. Dimension, the things that you want to split or group your data by. Metric is obviously the data you want to summarize and do the analysis on. And the high cardinality data, things like your device ID, things like your user ID, which only supports like unique count. What this does for us, it allows us to sort of scale Druid and use it, which is sometimes difficult if you are not careful around it. The other problem we came up with is the configurations. I mean, if you are operating at the scale we are operating on, obviously there is constant change around the data definition and requirement. We have all these different projects and that actually contributing to Druid, and many of them have their own configuration. How do you handle that constant change? How do you handle the consistency of data when they're coming from all the different data sources? We also wanted to have flexibility so that we can control the data retention I just talked about. Like we should be able to individually control the data retention. And sometimes it's hard to know the data loss, where it's coming from. Is it because the configuration, there's some problem with the configuration file, or there is just ingestion issues? So to come up with that, we actually had multiple different approach over the years. So we started with a very, very basic approach. We started like, okay, what if we just do blacklisting? So like we just blacklist the data we don't need. It's a very easy setup, but it's also extremely scary in the sense if you forget any data source, it's going to come in and it can cause DB failure very easily. So we moved away from blacklist to what if we do whitelisting? So maybe we can only categorize the data that we need as a whitelist. It worked. The problem is the management of configuration files. So now we have all these configuration files emitting from all these different projects. How do you manage that configuration? So some configuration might be like one project have one configuration and the other one might be different, and in some cases contradictory. So it becomes very complex to manage that. So what we ended up doing is we ended up building a configuration service, a microservice that actually manages the whitelisting, which means you can now guarantee the consistency across all this ingestion config file that you have. And a very high level, this is how it looks. So we manage all the config files as a config diff, a normalized config diff. And then we have the config service that constantly looking at it, understanding the differences, and then creating a config file. So now you might have, contradicting config file, but your config, service can actually take care of that. And the generated config file is now we version it with your Git or any versioning ID you want to do it, and then we can push that into a real-time ingestion. So we can push that into caller, and the caller can now have the latest and the greatest config file. At the same time, our real-time pipeline maintain, like the worker within the real-time pipeline can maintain its own cache. So but from some reason, if there is a config file doesn't get updated, it has a cache. So it's not allowing any unnecessary data. And then we have the batch ingestion to figure out if there is any sort of deviation or the historical data that we don't need in a real time. So again, this is one of our way to overcome some of the complexity that Druid generally has in production. The last thing we had to do is to come up with our own query engine. The query, to mostly abstract sort of the complexity around Druid query. If people who have used Druid, Druid doesn't really support SQL. Nowadays it does. It's, I think, recently they announced support with Hive, but it wasn't when we started doing that. It didn't have a very simple and interactive querying interface. The caching that we had with Druid was not really good for us to do it at our scale, so we had to come up with our own caching scale or caching API, which can support the frequent queries. And Druid also doesn't support joins, and most of the analysts want to do joins. So we had to build this API which can actually provide you all those capabilities. And finally, we had to build a UI that can actually sit on top of that. For some of you, again, who works with Druid, right now there are products like Imply, Superstate, which provides a UI on top of Druid. But when we started, there was none. So we had to build that ourselves again. And you'll see in the demo, I'll go through the UI a little bit. But this is, again, for us to hide the complexity that Druid produce. With that, I'll see if I can do a quick demo. Finger crossed. So this is the user interface. When you go into Glyph, this is the user interface you have. It generally has few things on the top. It has an interactive layer. This is where you go and write your queries. The query is a layer where you can see the past queries that you've run. You can also see any sort of queries that has been shared with you. Dashboarding is obviously where you can go create real-time dashboard. Funnels we talked about is allow you to build sort of conversion, sort of problem conversion engine. And page flow allows you to understand the flow of the users. So one page to another page, how the flow works. For this particular demo, I'm going to use some the usage data. So Glyph in itself is heavily instrumented. So we are actually collecting user interaction data for Glyph. And for privacy, we definitely can't use any of our production data. But what we're going to do today is to understand sort of the usage of Glyph with the data that we have collected through this. So let's go to the interactive query. And so this is what you get when you go into our UI. On the left, you have all the different sort of parameters you're gonna control. So we're gonna do Glyph usage, and we're gonna see how many Glyph queries were run in last 1 day. It presents you with a time series. You can now change that. Maybe 1 day is not enough. You probably want to know how it is for 1 month. So go with the 1 month. Again, it's really noisy because you can see we're sort of grouping them by 15 minutes granularity. Maybe we can sort of roll it up with a 1-day granularity. So what we're doing is now we're enhancing or using the power of Druid and summarizing this data into 1 day. So the entire days of data is now just one data point. And you can see there is a very cyclic pattern for our usage, which makes sense because there are weekends. So now let's see where these queries came from. So as you can see, all these different sort of pages within our UI, you can run queries. So maybe we want to know exactly what are the different pages the queries run from. So now what it's saying is, like, so we just had what are the top pages, and we limited by number 5. So now we're saying the dashboard is the number one sort of producer of the query, which makes sense because a dashboard has multiple queries embedded within a dashboard. The second one is a query that you can run from this query interactive page. So maybe you want to dig a little bit deeper into it. So one of the things that we built also is that how can you do more dig down analysis from here. So maybe you want to understand what are the different kind of visualization people are using when they're actually running a query. Just lost my mouse. So now it breaks down into time series, table, column, pie, and snaky. So this is, again, a view of how people have been using, what kind of views they are looking at in the time series. But maybe it makes more sense if you do it in columnar, like to understand the distribution. So now you've been presented with a distribution where you know exactly, what are the view types these different queries has been run. But one of the other things you can do is to understand from here is maybe you want to understand the number of unique users. So you want to understand how many unique users in the last 1 month has been running query within Glaive. And this is where the high cardinality data comes in the picture. So we can go uniques, and we're going to ask username. So because this is high cardinal data, we allow you to sort of count unique. And now suddenly you have a distribution that talks about that how many unique users have been running the queries. From here, we can save this data, save this query. And immediately you can now go to the dashboard and create a dashboard. So again, you can see like we had to do all these things to ensure that we can make this really easy for our end users. And it's like just from going back to our buy versus build choice, I mean, we had to do all this in-house just because there is no tools when you're doing it could allow us to do this. How we're doing with time. So quickly going back to use cases, we understand how the dashboard works. The question is what kind of actual use cases the dashboard supports. And over the last 6 months, the beginning of the year, we have seen like on average 6 to 10% people from within Hulu every month are using dashboards. So what are they using for? There are 3 main areas that we found that has been used. One is the real-time monitoring of the special events. And what the real-time monitoring of special event is, it's for Hulu, because we have a live TV service, as you know, things like World Cup and Super Bowls are extremely important. This is when we get a really large volume of people. We get a lot of scale in terms of how many people are watching it, but we also have to be careful, like what is the quality of service they're getting. So whenever we have any sort of real-time or special events happening, we want to make sure we can monitoring some of this quality of service, how the sign-up is working, and what is the scale. The way we do it is we obviously build dashboard within the Glyph, and then that gets widely shared within our product and engineering function. The other thing we use quite a bit of our real-time monitoring or the operational intelligence still is the feature launch. So every time we launch a new features, the product manager want to know how the product is functioning, how the features is actually doing. Is it driving any sort of real-time or the conversion the way they want to do. So to understand all these things, the product manager create their own dashboards, and it gets shared and it gets monitoring in real time. And the last thing we do, one of the major things is the monitoring of our health of the devices and our technology. And so every time we launch a new app, we want to ensure that the app performance is good. We want to understand how it's doing compared to the last app. What's the adoption rate of the new app? And in general, how it's performing. And this is where our engineering team, our engineering operation team uses Glyph so that they can monitor the performance. So finally, what have we learned from this? So it's been a journey that has been multiple years, so we haven't reached there in one day. So there are obviously different learning, and none of these are ranked in any special order, but these are the 4 big areas that I think we have learned a ton, and if you are trying to embark on a journey, it would be interesting and useful for you to focus. One is obviously data. Whenever you're building any sort of real-time system, the data lifecycle management is critical, because how much data would you retain? You can retain, like we had conversation with some of our users, they want the data forever, right? And obviously you can't really have the data forever in a real-time system. So it's important to understand the data lifecycle management so that you can actually have a strategy around that. Data governance is critical. You are ensuring the data is available in real time, and you're giving people access to it. Like, how do you ensure that governance of data is placed? How do you ensure cross-platform quality? We sort of touched around it a little bit earlier, because your data is getting generated for all these different platforms. You want to make sure they're similar, they're consistent, so that you can do analysis that makes sense. And the event time versioning. Like all the instrumentation we have in all the different platforms, they're constantly changing. Some of them might be a version ahead, some of them are a version behind, but how do you ensure they are actually consistently in the same space, if not the same version, so that you can get to that quality and the governance. Technically, scalability and performance is a big thing. Again, when you are processing 10 million events per minute, obviously it's a huge scale. So how do you handle that scalability and performance? What kind of strategy you would have around that? Response time is critical. Unlike BI, an operational intelligence system has to be extremely fast. If your query is taking 10 seconds to run, nobody's going to use it. So understanding the response time and able to provide the response time is key. Again, the SLA is key. You saw some of the use cases. We use this for extremely critical business operation purposes. So if you don't have a very stringent SLAs and you provide actual explicit support around that to sort of meet those, it's not going to be a useful tool. And finally, technology limitation and vendor locking. In some cases you might be using vendors, some cases like us, you might be using a technology like Druid, but any technology would come with its own limitation. How can you look beyond that and build your own technology around it to make it to abstract it away, to make it much more generally? And that's why we had to build our API, that's why we had to build our configuration service and so on and so forth. The focus is the third most important thing. It's like, for us, it has been, how can you stay business and customer focus? Always questioning that, what is the impact to the business and customer? Because this is a tool we're building for them. User experience is another important. If you make it extremely difficult for user, they will not use it. If you make it extremely easy, they will use it. It's that simple. You also have to make sure that you are having enough instrumentation within your tool. You saw I run the demo with all the instrumentation from this tool itself. How would you otherwise know the usage of the tool? How can you have the conversation with your users, like, is it even working for you? Or what change we can have? So user metrics and instrumentation to support that is critical. And build iteratively. Yes, we have this extremely powerful tools at Hulu, but it took us multiple years to get there, and we haven't gotten there in day one. It took a lot of learning to get there. So don't worry if it fails for the first time. And the final thing is the organizational, which is training, focus on training so that people know how to use this tool. Behavior and culture. We had a session in this room a little bit earlier talking about data literacy, and we actually had to do those quite a bit. How do you know you can have a conversation with your end user, explaining the real-time difference between the real-time data retention versus your historical data, and have that positive conversation that actually results into a positive behavior. And the data-driven culture, we all talk about that. It's, it's job for all of us. But again, for us at Hulu, it is a constant learning and having those conversations with our stakeholders, with our key, executive sponsors, with our stakeholders. Is like how can we help to build that positive data-driven culture? And the tool we have built is again a tool to support that, but there has to be more than just a tool, and there has to be a lot of conversation. That's all I have. I will take questions. I don't know how much time. I'll be sticking up after this, the meeting. I'll be in the, the networking. And so if you have any questions, I'll answer them there as well. Thank you very much.